Welcome back. In this video, we're going to talk about chapter 7 about thinking and language. Specifically, in this video, we'll talk about module 7.1 thinking. So, before we talk about thinking, a quick background information. If you remember from the history of psychology, we talked about how cognitive psychology is different from other fields and how it is the main, prominent, basic, fundamental perspective of studying human mind and human behavior. Cognitive psychologists specifically study the internal behavior, the mental processes related to thinking, language production, problem solving, reasoning, um, and and how we acquire these knowledge. So there are some basic fundamental aspects of cognitive psychology's assumptions that go under this particular topic. If you remember from the earlier videos, we said that cognitive psychology has three fundamental assumptions. Number one, that mental processes exist. Number two, that we can study mental processes objectively. And number three, that humans are information processing systems. So this unit is basically talking about two such mental processes. One is thinking in 7.1, and the other one is how we use language, which would be in 7.2. So let's get started with 7.1, thinking. So what is thinking? Well, you might be thinking right now about what thinking might be. Thinking is defined as a mental process of representation and manipulation of information. Representation and manipulation of information. Now, before we talk about the specifics of the definition of thinking, it's important that we understand the historical underpinnings behind the cognitive psychology and the fundamental ideas behind defining thinking. Now, it all goes back to scientist Alan Turing. If you watch the game, if you watch the movie, the Enigma, it's not Enigma. I think it's called the Imitation Game, which is about the machine called Enigma. It's the same Alan Turing. The idea here is that any system, if it acts intelligently, and system here includes humans, any system, if it acts intelligently, it acts so because it does two unique things. And these two unique things are that it represents information about the external world in the form of symbols, and that it can actually manipulate symbols. Now, let's talk about symbols in this slide. In the next slide, we'll talk about manipulation of symbols. Now, what is a symbol? A symbol is a representation of the object in the real world. For example, the symbol for, let's say, a coffee mug, which is an object in the real world. All right, let's assume, I know it's not a coffee mug. Let's assume it's like a coffee mug. So this is the actual coffee mug in the real world, and we represent that with this symbol that sounds mug or coffee mug. A symbol is something, a representation of the actual thing in the real world. Now, the important thing that makes a symbol is the connection between the actual object in the real world and its symbol that we use to represent it, which is completely arbitrary. In other words, the world will not change if we start calling a coffee mug a chalk and a chalk a coffee mug. Well, I hope you're having a nice coffee in that chalk. Well, it sounds odd, but it does not change the world. You can still continue to communicate. So, what makes symbols is this idea that they represent objects in the real world or ideas in the real world, and there is no real connection between them. And this particular thing is what makes a symbol. So going back to the intelligence, and as we said that a system is intelligent if it can store symbols and if it can manipulate symbols. So computers are intelligent because they store symbols and they can manipulate symbols. So also humans, we also store symbols and we manipulate symbols. Well, thinking then is, if you go back to the original definition we started with, is the mental representations and the manipulation of those representations. It is how we develop representations of the objects and ideas in the real world, and how we manipulate these will make up thinking. In this particular video, we'll talk about thinking as representations. In the next video, we'll talk about thinking as manipulation. Remember, what we're saying here is that thinking involves manipulating the representations or manipulating the symbols we have in our mind. So we need to know what these symbols are. In other words, what these representations are first before we can talk about the process we use to manipulate this representation. So that's why I've divided this a particular topic of 7.1 thinking into two videos. 7.1 about the nature of the representations or symbols, and 7.2 is about how we manipulate these representations. So coming to the representations. Now, how do we represent the information? In other words, how do we represent the objects or ideas in the real world in our mind? Well, there are, according to the scientists, there are two different ways we can represent information or objects or ideas in the real world. One is in the form of pictures or images. It's called mental images. The other is more abstract in the form of words or concepts. A very, very fundamental distinction between these two at a very basic level is that one is pictorial, more like analog. The other one is more digital in the world, in the sense that there is no real um, representation of it in a pictorial format. So it's pictorial and non-pictorial, or mental images and words or concepts. So first we'll talk about pictorial representations, then we'll talk about the non-pictorial representations. So coming to the pictorial representation, the images. Now, what is an image? Well, an image is a picture or a sensory representation of an object or an event in the real world. So when I say apple, well, did you figure an apple, an image of an apple, in your mind? Well, that is an image, right? So an image is a mental picture, a sensory representation, a sensory symbol of the actual object or event in the real world. Now, keep in mind that the system that stores this information it stores in a way that you can actually manipulate these images. Now you can think of, close your eyes and think of I don't know, like think of a kite and maybe flying it, or maybe pulling it down from the sky, and maybe twisting it, or breaking it, or rotating it. Well, you can, with the pictorial images, manipulate that visually or pictorially. Now, I say pictorially here, picture here, or pictorial here does not necessarily represent visual. It can, it is not limited to visual images. It can be related to auditory, any sense organ. It can be gustatory. It can be tactile. It can be related to smells, touch, related to five different sense organs. So the idea here is that it is in a sensory format. It's a sensory representation of an object or even in the real world. um, and sometimes this can lead to solving some problems, creative solutions, coming with nice new novel solutions to finding problems. Again, we'll talk about this in the next video when we talk about problem solving and manipulation. Now, one important thing about these images, whether it's visual or any other format, and more particularly more related to the pictorial one, the visual ones, is that we can manipulate, right? Under this idea of mental rotation, and according to this, we can mentally imagine an object, and you can mentally rotate an object. And researchers have found that we take same amount of time, or at like approximately same amount of time, to physically rotate an object. Um, um, Same amount if we were to mentally rotate the object. What researchers did in one of these experiments is they presented participants with pairs of images like this, and the task was to decide if these two objects of a given pair are same or different. Now, especially now for these are different, these are same, and for the object that are same, what they manipulated was how much of a rotation, angle of rotation there is between the original object, the first object, and the second object, whether it was small or it was more. In other words, um, an individual need to compare um, two objects with a different orientation, with a lot of rotation required to compare versus a small amount of rotation to be compared. What researchers found was that participants took longer time if the angle of rotation between the two objects was more, when compared to when there was a smaller angle of rotation between the objects. In fact, it was in line with the actual time taken to mentally rotate an object, suggesting that we use pictorial, or at least visual representations, in a way that we actually this is called embodied cognition. We use it in a way that it is in real time. Now, coming to the second